Okay, so let's say you've gotten your quadratics down, and you've got your regular functions down. What if you've got polynomial functions? Functions with higher powers than just 2. Well, there's a process for that too. And if you're going to graph them, here's how. First, you gotta find the symmetries of the graph. Let's start with an example, and we'll walk you through it on this. According to Gustafson and Frisk's book, I'm using their example, where f of x I'm sorry. F of x is equal to x cubed minus 4x. So first, let's find the symmetries of the graph, if there are any. So let's try f of negative x equals negative x to the third minus 4 times negative x. Simplifying this down, we've got f of negative x is equal to negative x cubed plus 4x. Now, this is not equal to this. We've got complete opposite here. However, the function of negative x is going to be equal to the negative function of x. Negative function would be that, which means it would be flipped around, and that would be equal to this. So that means it's going to be symmetrical about the origin. Step 2. Find the x and y intercepts. Well, to find the y-intercept, you set x to 0. So, x cubed minus 4x, x cubed minus 4x equals the f of x. Now 0 cubed minus 0, 4 times 0, I can rewrite that, will be equal to the function of 0 equals y equals 0. Okay, so the y-intercept is 0. If we set the y equals 0, we can get our x-intercept, where x cubed minus 4x equals 0. Subtract 0, subtract 0. Sorry. Here's where we factor this out. Sorry, we can't turn this into a quadratic. So what can we take out? Well, we've got an x here and an x here, so let's take that out. So we've got x times x squared minus 4. Hey, a difference of 2 squares. That's an x plus 2 and an x minus 2 factor there. X times x minus 2 times x plus 2 is equal to 0. Now we set all of these to 0, and that's our x-intercepts. Now, remember that actually, if you have a polynomial to an nth degree, the number of turning points, in other words your x-axis, intercepts, it's going to be your nth degree minus 1. So if it's to the 4th power, you're going to have 3 turning points. So we've got a 3rd power here. There's going to be 2 turning points. So we've got x can be 0, x minus 2 can be equal to 0, or x plus 2 can be equal to 0. meaning x can be 0, x can be 2, and x can be negative 2. So those are all our x-intercepts, that's our y-intercept. Step 2 is now complete. What's step 3? Well, let's determine where the x and where the graph will lie on the axis. How do we do that? Well, we take our x times x minus 2 times x plus 2, our factors, and we put them on a number line. So let's see, we've got x can be 0, so we'll put a 0 here. X can be positive 2 and a negative 2. And then we divide this line up. So it can be anything past here. It can be anything in between here. It can be anything in between here. And it can be anything past here. So, let's look at this. And pick out a random value and put it in for the and then you put it in to the original equation, something that fits in each of these ranges. So let's see, negative 3. I'm going to do some off-screen calculation here. Negative 3 cubed is going to be equal to negative 27, and then subtract 4 times negative 3. So subtract negative 12. So that will be equal to 15. Negative 15 is a negative number, so we mark this as negative. Next, we put in a range between negative 2 and 0, so negative 1. Now, negative 1 cubed is negative 1. Then subtract 4 times negative 1, and you get 3. That's a positive number. Now you've got 0 and 2, so let's switch it about. We've got 1 cubed, subtract 4 times 1, negative 3. Negative number, we mark it with a negative. And for here, we've got 3 cubed minus 4 times 3. This becomes 15, which is positive. Why did we do that? Now, why did we do that? That means that each of these signs stands for where the graph will lie on the chart. So, if it's going to be less than negative 2 to negative infinity, it's going to be below the x-axis. It's going to be in the negative y's. If it's between negative 2 and 0, it's going to be above the x-axis. And it's going to do that little wave there for the next 2. But where's it going to lie? This is where we do our math. Okay, so now we've got some factors. And we know where the graph will lie. Using the factors here, we can tell where it's going to be above the x-axis, or below it. So let's do a little bit of math. X cubed minus 4x. Let's plug in a few values for that and see what what we get for our y-axis, and then we'll graph those points and then draw our line. It's going to be a smallish line, but let's see. Here, I'll just use this space, x and y. Let's graph 4 points. How about -2, 0, 1, and 2? Well, -2 cubed is going to be equal to -8, and then subtract your 4 times -2, which is -8. So that's -8 minus -8, which comes to 0. Now remember, this means that when you are on the x-axis at -2, you're going to stay on the 0 on the y-axis. So -2 and 0. That's our first point. If we've got 0, that's 0 cubed, which is 0, minus 4 times 0, which is 0. 0 minus 0 is 0. Now, we go to 1. 1 cubed is 1. Minus 4 times 1 is is 4. So 1 minus 4 is -3. So 0, 0, and 1, -3. Then we get to 2. 2 cubed is 8. Minus 4 times 2 is 8. 8 minus 8 is 0. So, when we get to 2, that's where we are. Now, here we go. This is where this part comes in. Graphing. Okay, is it below -2? Then we're going to be under the x-axis. So here we are below -2, here we are, -2. Now between -2 and 0 will be above the x-axis. Here we go, we come back down again. Now normally you would be graphing where this vertex would be your local maxima, and here would be your local minima. I won't tell you how to do them because it's very easy. Just find your highest point here, your highest point here, and your lowest point here. It's not too hard actually. Anyway, you're here at 0. Now we go back down below the x-axis, and we're going to hit this point here. That would come then from there. Okay. Now, we've got our plus here, which means we go back all the way up, and that'll be the end of our graph. So it looks a little bit like an S-curve. And that is all you have to know to do polynomial functions. First you've got to find the symmetries of the graph. Then you've got to find your x and y coordinate or intercepts. Determine whether the graph is going to be below or above the x-axis using the factors and a number line. Then plot a few points out on a graph using the original problem, and then draw the smooth graph line according to all of your data here.